I'm Guojin. Everyone calls me GJ at GetGround. So I did mathematics as an undergrad, and sort of stumbled into data science early in my career. That's how I met Misrab, the CTO. So I met him at GetGround, and we moved along to Gojek, where we did ride sharing in Indonesia. I was productionizing a lot of data science model, and I realized I actually much prefer the engineering aspect of it. And so when he decided to do a startup in UK, he asked if I want to join him pretty early, and yeah, that's how I got involved with GetGround 2 years ago. Yeah.
Super cool. And so you're based in our London office, GJ, right?
Yeah.
Yeah. Perfect. And so from London over to Singapore and to Jiling, who is in our DevOps team. So Jiling, would you like to share your background?
Yeah. Hey, I'm Jiling. I also kind of stumbled into engineering from into software engineering from a systems engineering background. And I've been steadily moving towards more of the infrastructure side. So at GetGround, I take care of the infrastructure, deployments, basically all the SRE stuff. And we're really looking to grow our team here. Yep.
Awesome. Thanks so much. And then over to Pierre on the front end.
Hi everyone. So I'm Pierre. So gonna be a year that I've been at GetGround. So I'm a front-end engineer, also team lead. So as for me, I've done a computer science degree back in France with the ingénieur title. And then I did my last internship moving in London. So I've worked for more than 2 years with a company called Orthos that was building a protocol on the Ethereum blockchain. And then after 2 years with them, I've moved at GetGround. And yeah, that's pretty much me. So I love solving stuff and just stumble onto front end where it's lots of fun things to solve. So yeah.
Super cool. And so I've seen there's a few more people have joined the session. So welcome to everyone that's joined. If you'd like to add any questions in the chat box, we'll then have a Q&A session at the end of the discussion. Perfect. So I think over to GJ, who's going to give a quick overview of GetGround, because not a huge number of people know about GetGround as we come out of stealth mode. So could you just give a quick overview of what we do and who we are, GJ?
Yeah, sure. Good afternoon, everyone. Thanks for joining us in our first webinar. I believe many of you guys are new to the property tech scene, or at least with GetGround. So today I'll be starting off the presentation, covering a few main aspects. Firstly, who we are as GetGround and what do we do? How do we bring value to the traditional property market? Secondly, where are we at right now after 2 years of launching a web app? Lastly, what are the main challenges that we face during the early phase and what are the key takeaways? At GetGround, our mission is to make assets more transparent, trustworthy, and accessible. And we're doing this by bringing the world's asset online, starting with residential property. We believe that increased access to asset ownership will create a fairer and more productive world. Okay, this is pretty abstract. So concretely, what we do is we make it more affordable and easy to use a limited company to buy property for buy-to-let purpose in the UK. There are 3 advantages to this approach. It gives the property a legal identity. We makes it easy to open a digital wallet, creating transparency over the cash flow. Secondly, it means that multiple people can own and govern a property together, making it more effective. The idea of and concept of shareholders in a company is pretty familiar, but joint ownership for property is a lot more complicated. And thirdly and lastly, it creates liquidity because the shares of the company can be bought and sold much more easily than the underlying property. Yeah. And
perfect. So I'll share. I'm just going to share my screen, and so visually we can see what we do. I don't know, GJ, if you want to give any more kind of color as to this.
Yeah. So this picture actually sums up what we actually do at GetGround. It's quite a lot. Firstly, we do company formation. We programmatically incorporate and web file companies with the company house. We do electronic agreements. Users can sign legal documents in our app and keep their company's document organized in our app. We do digital wallet is one of our big offering. Users can use our in-app digital wallet to collect rent, pay mortgages, and organize their expenses. We also support currency exchange because we have a lot of international customers from countries like Singapore, Hong Kong, Middle East, and even Africa. To be told, my geography knowledge actually increased quite a bit working here. It's quite a lot of countries that I didn't hear before. And lastly, we're working towards a marketplace for buying and selling shares of companies that house their property within GetGround. In a nutshell, you can think of us like DocuSign, Monzo, and TransferWise, some functions of it that you can use to manage your buy-to-let property. Yeah.
Awesome. Over to you again, GJ.
Yeah. This is actually not a heat map of COVID-19. This is a heat map of the properties under GetGround from August 2019 to this month. I plotted with Capo GL by Uber. The higher the color intensity, the more GetGround property they are in the hexo bin. As you can see, Manchester is a pretty popular area last year for property investment. And overall, we're growing pretty quickly. Month over month, our sales growth has compounded 50% last year. And this year, we're trying to bring about a total asset value of £1 billion this year on our platform. Yeah, but there are a lot of pains that come with growing, and here are some learnings that I learned the pretty hard way.
Yeah, so we've got 3 insights that we're going to be sharing with everyone. And so the first GJ is going to take us through is building processes early.
Yeah. So one thing that really helped us was to build good processes early. So firstly, start building them very early. I remember at the start of the GetGround, before we even have a web app or even a product, the teams are split into front-end and back-end engineering. The front-end engineering was building based off designs, and the back-end was constructing REST API nonstop from the database model that we thought is suitable. We thought we were super productive because all the programmers were coding nonstop. However, when we get closer to demo day, there were a lot of integration issues with the front end and back end. And we realized that there was a lot of unnecessary route that the backend engineering actually written. The solution was actually pretty simple and pretty ridiculous. Now that I think about it, we actually moved office, and the new office actually had a whiteboard, and we had much less integration issue. The fundamental problem was we weren't doing whiteboard session, so it would be much better if we started doing whiteboard session way earlier before we even had a product. Next thing that I learned is process are important because mistakes will happen. Anything that can go wrong will go wrong. Third party will fail. Your customers will fill their information wrongly or even sign wrongly. A good example that happened was in Hong Kong. Hong Kong actually doesn't have postal code. I learned this on this job too. I never stayed in Hong Kong before, and so when we designed the front end input and we made the input field for postal code to be required, the Hong Kong customer actually get really confused. And we had to fix that basically on a hot fix because a lot of our early customers were from Hong Kong, and it's pretty stressful to fix it. So one thing that makes a lot of sense is have an undo function. For example, we save a lot of time and energy by building functions to regenerate the signing of legal document. So when a mistakes happen, we can easily rewind and the customers can re-sign on the corrected legal document. right? My last point is processes can actually help you form good habits. The common thing, you know, in any startup environment that I've been is, you hear is, I'm super busy. I don't have time for non-essential, but there are a lot of non-essential tasks with a lot of positive externality. One such example is having good documentation. It's fairly important to document why good designs decisions are made, instead of, you know, finding out from someone the day before they left, like, why is, you know, this code is written a certain way. A process that worked pretty well at GetGround is to create RFC before things are big design decisions are made, especially on the back end. RFC is a short form for request for comments. It's designed to help team member propose a solution to a problem and get feedback on that proposal. So a typical template of RFC would include things like the problem statement, the proposed solution, the alternative solution that was explored, and key milestones. Yeah. So just to recap, it's never too early to start having good processes. Mistakes would happen, so have a plan in place and form good habits with processes. Yeah.
And GJ, before we jump over to Pierre, what would you say is the trade-off between wanting to build features versus the scalability of the product? Because, like, we obviously have huge ambitions to continue growing the user base in the product. Keen to hear your thoughts on that.
Yeah, so that's a tough question. I thought you were on our side, but I think it depends on where you're at. I think it's inevitable that at the start of the early stage of the startup, you prioritize building and getting the product out to make sure, you know, you have a good product market fit. But as you go, I think it's quite important to build processes to make sure you know where are the key areas of improvements in terms of tech debt that you want to take on, and prioritize them along with product decision. So make sure you create a healthy backlog of tech debt for your engineers, and make sure that, you know, you're able to prioritize it along with product requirement and product feature as you get more mature. Yeah.
That's great. And we'll be having future webinars and hosting other members of the product team. So that's great. Thanks, GJ. Okay, now over to Pierre, who's going to discuss considering component libraries to scale.
Thanks. So hi, everyone. So when to consider building a component library, what we add and what we change. So as DJ mentioned, so having processes early is very important, and so is having good tools and good solutions. So a bit of background at GetGround. So why would you want to get a component library? So there's multiple reasons you would want that. So obviously there's the idea that you want the dry principle, so don't repeat yourself. Obviously having a single place where you share your code is obviously a good way to address the dry principle. You also want style consistency. So whether if you create a component that works across multiple browsers, and you want to reuse that one, surely you need a place to share that. And ultimately you want a single source of truth for all your components. So you don't want to have them in 3 places, modifying one place and surely forgetting the 2 others. So single source of truth is also an extremely important principle, especially when building a component library. Few requirements in order to build a good component library. First thing, you need to make sure that the business has enough time to invest for that component library. I think way often what happens is that people are too eager to build a component library when they don't have the time for it, and the business won't allow that much time. If you want to build it properly, make sure you are given the time to do it the right way. Otherwise, it's going to be a failed attempt, and I'm going to speak very soon on what happened at GetGround. Also, make sure that if you do have designer or people involved with design and styling outside of your front-end engineer, make sure they're involved because they will need to comply per this new system. So use it in like any SketchUp they will come up with, any design, they will need to use the same system as your engineers. That's also extremely important to communicate the right things. And last but important, have a clear idea of why you want to build that component library. So jumping into, so on the first line, you can see at the moment at GetGround, we've got 2 applications. So one for the customer, facing the customer, and one as the back office. As DJ mentioned, we'll have the marketplace at the horizon of 2022 or at some point. We're also gonna surely open up not only to the UK market, but more markets, meaning we will need more customer app that will change slightly based on the country. Hence why the component library is so important for us. So one of the things that happened, so when I joined GetGround, we actually had a 3rd repository, which was an application called FE modules for front-end modules. And we had a lot of problem, and this was basically a bad implementation of a component library. So one of the issues we had was, for example, we didn't add only dummy component. So we had smart components that were not only carrying their own style, but also their own logic, like the business logic, meaning that we could only reuse them in a few places, but we couldn't reuse it for like a different part of the business. We had to push compile code. Again, due to time, they couldn't put the right automation, so we had to push compile code. And all in all, this was a lot of problem because the full cycle time between someone who would need to build a component, compile, push it to the repo, pull it into the right application, try to see if the integration is correct. If not, repeat. So that would be easily 15 to 20 minutes just lost in pulling, pushing, compiling the code, and so on. So all in all, I'm really emphasizing on don't start building a component library if you can't, you don't have the right time to do so. As per GetGround, as we can see here, so we are moving from 2 applications to likely 4, maybe even a bit more. We're currently 4 front-end engineers, and we're roughly looking at being 10 in the upcoming year. And also we have 2 teams at the moment, and we're very likely going to have a 3rd team by the end of this year and a 4th team that's gonna come at some point. So all in all those considerations are very important because you wanna make sure that whenever an engineer will be working on one application with one component, you need to have one place where everything will be properly centralized, this single source of truth. So if someone needs to update it, then it would be true for everyone. And the most important thing, so one of the things I would also emphasize a lot, regardless of where you go for your the technical implementation of your component library, make sure that your component library is easily discoverable, not only per your engineer, but anyone in the business. By doing that, you will make sure that any new person that joins, so any new engineer, will be able to look at existing components, reuse them or expand them, instead of having like duplication of component because they're not easily visible and discoverable. So that's for the kind of the approach and diving into the technical options. So we had 3 options that we explored at GetGround, and I'm gonna try to go in depth, but not too much on those. So the first one, which might be the most common for everyone, is the use of Lerna. So by doing so, you will use the approach of what we call the monorepo. So the idea that you will leverage the Git sub-repository in order to be able to have one big repo that will comprise all of your application plus the component library. So the benefit from that will be it's really easy to use. You don't have to use NPM for that. You just refer to the actual Git sub-repository. So it's very easy to use within your component. But CI can be complex because you will have multiple applications. There's also going to be some problem around like restricting some access towards some repository or not, because everything will be under one big repository. And also that could be potentially the biggest issue. This will be only for internal use for anyone being in the organization. So you have no way for ultimately making it public to anyone. That's not possible. If you want to go for what I call the homemade approach, that would be the idea where you would be using NPM or Verdaccio. So Verdaccio is only optional if you want your command library to be private. So you would use those 2, which is already more complex. And regardless of if you're going with Lerna or the homemade approach, you're also going to add on top at least one bundler. So Rollup.js is the most common for component, but you could also use Parcel or other flavor. But you will also need Storybook on top or something, as I've mentioned, discoverability is extremely important. So you will need to also add that on top yourself. So that's a lot of tool to blend together. So Lerna will be quite fast to implement with the problem knowing of the CI and the permission. The homemade solution will be actually on point, but it's going to cost you quite a lot of time to set up and make it very nice, because you also have to consider the automation and so on. Ultimately, the third option we went with at GetGround is called bit.dev. So bit.dev started in 2018. So it's an open project, which is Bit, the concept of Bit, and bit.dev is the solution on top. The idea is that Bit will allow you to have a versioning control, which will be done to the component with the idea of a plug and play. So you can either decide to have a single place where you keep your components, so a Git repo, but you can even not use that and having them purely on Bit, where you could basically be in your project, pull a component within, make the modification, commit those, push those, eject the component, and then import only the reference to it. And then you know that whatever modification you've done, just like any repo, you can commit your modification, make them available to anyone to pull, and they will have the latest. On top of that, bit.dev will leverage, so not Storybook, but they will have their own discoverable system when you can see, play, modify some properties on the component. So all in all, it's a very good solution that we decided to go with. And the bigger reason for us was to be able to have something that is one solution for all, and that wasn't too time consuming for us. Last thing I would say for bit.dev, so very easy to start with. It's quite hard to master, and it's still in the early stage, so there's still quite a breaking change per the version they're modifying. But all in all, it's looking very promising, and most of the front-end community agrees that this will be basically the equivalent of Git for the components moving forward, hopefully. So.
That's super interesting, Pierre. And so obviously you mentioned like version control, bit.dev, and as we increase in complexity, I'm wondering what other technologies we're looking into or will likely be looking into in the next like 12 to 18 months.
Yeah, so I did mention that, but so we're using React at GetGround. So we're already using React and Redux in order to manage the state of like large application. One of the things we've realized though is that we're not really happy with the way we're orchestrating the data, and very likely that on the new project we're going to tackle, we're going to see that if the orchestration stage can be pushed down to the front end, and in order to leverage that, we're very likely going to look at GraphQL. In order to be able to control just what we need in the front end and not having to basically nudge the back end every time we need a slightly different piece of information if those are already available on the back end models. Yeah.
That's super cool. Thanks so much, Pierre. Great. And over to our final presenter, so to Jiling, who is going to discuss designing for damage control. Over to you, Jiling.
Yep. Thank you, Andrew. So as my colleagues have probably mentioned, we've been undergoing a ton of growth over the past year, not only in terms of the customers we've been getting, but also in terms of team size, and also the amount of functionalities that we've had to support on the application has been increasing as well. So as a result, our infrastructure has changed quite a lot over the past 1 year. Previously, we were mainly using managed services on G-Cloud, and we recently started moving away from that as our services evolve, we get more of them, and they're required to do more. So as you can see from this diagram, we have a mix of both managed services as well as self-deployed applications on Kubernetes. On Kubernetes, we've tried to mimic the experience of using App Engine as much as possible by using Knative as well as Istio. So as a result of all these changes, I've really had the pleasure to be able to build the infrastructure here pretty much from maybe not ground zero, but like ground one, right? And I would love to share some of the considerations that I've had throughout the process with you all. So the key tenets of a good system would be these 4 things, right? The first is availability, which is the probability that a system is up and able to serve traffic at a given point in time. The second is reliability, which is the ability to run correctly for a long period of time. The next one is safety, where any sort of failure does not lead your system to catastrophe. And the last one is maintainability, which is the ability of your organization to repair things when things do go So I'm not going to dwell too much on availability because it's pretty straightforward. Most people practice it. The main approach to dealing with availability is to have redundancy. But for reliability, something that I learned when designing GetGround's infrastructure and building it up is that most importantly, don't spread yourself too thin, because in the end, you are limited by the number of people who can manage what is currently running on the system. So an important thing to think about here is that there are two types of components or services that are deployed on the system, right? The first is stateless, and the second is stateful. So the nice thing about stateless components is that they're simple to manage over a long period of time. With sufficient redundancy, these stateless applications can just be turned off and on again, and they'll essentially continue working. But when it comes to stateful components, such as databases, caches, caches to a lesser degree, they're a lot more complex. And when things do go wrong, it's a lot harder to recover from it. So if you don't have the bandwidth, what we decided to do is to go with managed services for stateful components. So if you can recall from the diagram before, we are still using Cloud SQL for our backend. And we are also using a managed Elasticsearch service. And the important thing to take away here is to strike a healthy balance between what you own and manage and what you're able to put in effort to maintain. Yep. And when it comes to safety, something that should be obvious, but it's not something that most people implement when they first start building a system, is to always have an undo button, right? And this applies to all facets of the system. For deployments, you really want to be able to, whenever you roll out a new version of the app, to be able to instantly roll back to a stable version and have that stable version be serving traffic at any moment's notice. So when moving from App Engine to Kubernetes, we made sure to set up a framework that allowed us to perform these blue-green deployments, which is a huge reason why we decided to use Knative, which had very useful abstractions for doing this. And something that I can't overstate is that when you're testing your application, always test the undo button. I think we've learned this the hard way. We've tested changes in CI in the forward path, but rarely do you think about thinking to test, should I test if my DB rolls back currently? Should I test if my application rolls back currently? And when things did go wrong, I think about 2 months back, we learned that our rollback functionality wasn't properly tested, wasn't properly up to date. And there was a bit of chaos for about like 30 minutes until we got it working again. So now what we do is that we have a CI deployment that comes a few days before the actual application rollout every 2 weeks. And what we do during a CI deployment is to test all facets of the CI, the forward path, the backward path, ensuring that all the migrations work, all the rollbacks also work. Yeah, and we found that that has benefited us quite a lot. And no, we're still on safety. So when it comes to the undo button, it's not only for deployments, right? It's also for infrastructure, which is why we define our infrastructure as code using Terraform, which is also version control. So any erroneous changes to infrastructure can easily be rolled back. And thankfully, it hasn't really happened here. But if, let's say, infrastructure gets taken down, it can easily recover to previous stable state. It has happened in my previous company, and Terraform really, really saved our asses there. Yeah. So for maintainability, what you really need for maintainability is to give your developers the tools to find out what's wrong with the system. And when it comes to working with distributed systems, it becomes a much larger problem to network and debug the problems compared to when you're working with a monolithic application. because now you need to track a request live across multiple services rather than a single service. And if you don't set up your logging and your tracing to do that, it will become a nightmare for your developers to figure out what's the problem, get to the root cause, and solve the problem in a timely manner. So what we've done is that for logging, we always have a trace ID that uniquely identifies every request. And this trace ID is propagated across downstream requests via the context. And downstream logs are published under this same trace ID, which can be used to filter for related logs when something goes awry. And the usefulness of this is that then you get the full context of the logs, right? Upstream logs will review the context behind errors, and downstream logs will review root causes. And to take the tracing further, we can also pick up things like Jaeger, which allows us to more carefully monitor the lifetime of the request across all multiple services. Yeah. So that's more or less what the key learnings that I've had when building out our infrastructure. And yeah.
That's great. Thank you so much, Yiling. I was going to ask, what has been your biggest challenge since joining GetGround in terms of the infrastructure?
I think one of the biggest challenges when it comes to infrastructure and deployments in general is that a lot of the information that we deal with is extremely important to our customers. So when we are dealing with anything that is stateful, anything that deals with the DB, we have to be extremely careful. So I shared the experience where previously we learned that one of our rollback functions wasn't working, and I think that was quite challenging to solve, because then we saw that our application was out of sync with the database, and we had to quickly fix that on the fly. And thankfully now, after learning that lesson the hard way, we've built up an automated system around that, tested all our rollback functions and made sure that it works.
That's super cool. We've got a couple of questions coming in. So one from Errol, who's asking why we don't use Cloud Run instead of App Engine. I don't know if GJ or Pierre, one of you would like to take that one.
Yeah, I think solve a legacy decision. We're using App Engine before all of us started, and so the deployments was already set up, and it's something that is pretty easy to pick up, and so we started using it, and we kept with it until there were more needs to change our infrastructure. And that's where CL start exploring other solutions such as Knative and Kubernetes.
Yeah, that being said, I think App Engine was probably the more appropriate solution, because our application wasn't exactly a serverless workload, and we wouldn't be able to leverage the key benefit of Cloud Run, which is the scale to zero, right? And since our application was constantly working, because it was monolithic, right? It was constantly working to do synchronizations with third parties and all that. It just made sense to have a persistent instance in in App Engine instead.
Cool. And then how do we test API requests? Pierre, do you want to take it?
Sorry, yeah, I can try. So we're not testing the API request per se, at least nor on the front end nor on the back end. We're really testing with the behavior, so the user behavior. So ultimately, we would test the API request, but just not the API request. We actually test the behavior with our components. We've got end-to-end tests. So ultimately, if one of the endpoint was to change, then the end-to-end test with Cypress should pick it up. We've got in the pipeline the idea of using Gatling, so along with also testing the load when like trying to overwhelm our API, we could also add just testing that the API are consistent, and whenever the backend change them, we know that it indeed changed in the way we expected. Yeah, I don't know if I've answered the question really well, but
yeah, just to add on, I think on the back end we do of course at the start we do unit testing, test the functionality and the domain logic, and usually on our local dev environment we do local postman testing after we spin up the backend locally, and after that we move on to the QA stage after we deploy to staging. So our QA is able to test it on our sandbox environment. And
I think it's a good point to move over to our team structure, so how the teams are set up, because obviously we have a QA per team. GJ, would you like to share how we set up our teams, our tech teams?
So our teams are set up such that they form units that can tackle and deliver complete features within the team. And so within the team, there are front-end engineers, there are back-end engineers, there is a product designer, and there is a product manager. So they should be independent and able to deliver a full feature and take care of that feature end to end. Currently, we have 2 teams, and the team is getting fatter, but we're looking into breaking them into like a more team, and we're hiring actively.
And I suppose because we're building really the first end-to-end product of its kind, certainly within this space, and there's a lot of complexity. We're like a company formation agent, we're like a document signing platform, e-wallet provider, currency exchange, accounting solution. There's so much. I wonder how you think about simplifying and reducing complexity as much as possible. If you had to summarize it in terms of our approach to that from an engineering perspective.
Yeah, I think that's a really, really tough question. To support multiple flow and multiple provider, I think it's probably the reason why we're moving away from monolithic, because we realized that the code base is getting, at least on the back end, is getting really heavy for anyone to hold it in anyone's mind space. And so I think there are a few ways to actually tackle this kind of complexity. One is cutting it into microservices, but making sure that there's nice interface in between the microservices, so that the teams just need to be concerned over the interface they're working with. So reduce complexity for all the engineers. Just focus on getting the service right. Another thing that makes sense for front end, for example, is reducing it to component libraries, as Pierre went through with us, and make sure that things are better managed, better organized, and as human resources also break down into teams, and so within a team they should be able to handle end to end. It's still pretty challenging, besides everything we've done. Complexity is always catching up, and I think it's kind of like as you add more features, things will be more complex, and you just got to be more aware, like, okay, where are the things that need solving, and prioritize tech debt ruthlessly, and sometimes try to bump up certain tech debt and prioritize them even ahead of product release, to make sure that everyone got a pretty nice dev environment to work with.
That's cool. And I suppose over to Xiling for maybe one final question in terms of you being the only infrastructure or DevOps engineer at the moment permanent with us. What kind of trade-offs do you have to make? Because your role is obviously super critical to the the maintenance and of GetGround. So how do you approach that?
Hang on, sorry. I was just thinking how to segue into telling you that Timur has a question. And let me answer that first. He asked, how do we do integration tests with external APIs? And thankfully, most of our third parties have sandbox environments, and we just connect to those. That's how we do our integration tests. To Andrew's question, yeah, so I mentioned earlier that it's really important to know what you can manage and what you can't, which is why we've been pretty reluctant to migrate off some of our managed services. But of course, with more and more manpower, we're able to take things more into our own hands. And I'm looking forward to do that in the future. Yeah.
Perfect. Thank you. Thanks so much. Thank you, everyone, for joining. I hope you've enjoyed the session. I certainly learned a lot, and we will be sharing our first blog post shortly. So do please follow us across the different social media channels, and yeah, we're really looking forward to having more webinars in the future, and to welcoming you as part of our GetGround community. So thanks so much, and have a great rest of the week.